Let us now work on some integrals that involve the use of trigonometric substitution. So we evaluate the integral of x squared, square root of 9 minus x squared dx. 9 minus x squared is of the form a squared minus u squared. So a is 3 and u is equal to x. For expressions of the form a squared minus u squared, we use u equal to a sine of theta, or x equal to 3 sine of theta. The differential is dx equal to 3 cosine of theta d theta. Okay, so we now apply this to our integral. X squared will be equivalent to 3 sine theta quantity squared, square root of 9 minus x squared, which is also 3 sine theta squared, and dx is 3 cosine of theta d theta. For the radicand, 9 minus 3 sine quantity squared is 9 sine squared theta. We can factor 9, 1 minus sine squared theta. And 1 minus sine squared theta is cosine squared theta. So, 3 sine theta squared is 9 sine squared theta. Square root of 9 is 3. And the square root of cosine squared theta is cosine theta times 3 cosine theta d theta. That will be equivalent to 9 times 3 times 3, or 81 sine squared theta cosine squared theta d theta. Sine squared theta cosine squared theta falls under case 4 for powers of sine and cosine, where both exponents are positive even integer. So we shall apply the identities. 1/2 1 minus cosine of twice the angle to theta. That replaces sine squared theta. And cosine squared theta is 1/2 1 plus cosine of twice the angle, which is also 2 theta d theta. So 1/2 times 1/2 is 1/4 times 81 is 81 over 4. 1 minus cosine 2 theta and 1 plus cosine 2 theta, it's a special product, equal to 1 minus cosine squared 2 theta d theta. So we continue. 81 over 4 integral of, okay, so we can integrate d theta, which is theta, minus, but for the integral of cosine squared of 2 theta, we apply anew the identity 1/2 1 plus cosine of twice the angle. 2 times 2 theta becomes 4 theta d theta. Okay, so that will be 81 over 4 theta minus 1/2 of d theta, that will be 1/2 theta, minus 1/2, and the integral of cosine for theta is 1 over 4 sine 4 theta. Let's see. So that will be 81 over 4 theta minus 1/2 theta is 1/2 theta, or theta over 2, minus 1/8. Sine 4 theta is equivalent to 2 sine 2 theta cosine 2 theta. Alright, so we are trying to express sine for theta in terms of sine theta and cosine theta. So we'll start with sine for theta, which is equal to 2 sine 2 theta cosine 2 theta. So that is now 81 over 4 theta over 2 minus 2 over 8 is 1/4. 1/4 of sine 2 theta. Again, sine 2 theta is equivalent to 2. That is equivalent to 2 sine theta cosine theta. While cosine 2 theta is equal to cosine squared theta minus sine squared theta. Let's see. So, 81 over 4 theta over 2 minus 2 over 4 is 1/2 sine theta cosine theta multiplied to cosine squared theta will give me sine theta cosine cube theta. And then sine theta cosine theta multiplied now to sine squared theta will be equal to negative sine cube theta cosine theta. Let's see. We can factor 1/2. So 81 over 4 times 1/2 is 81 over 8 theta minus sine of theta cosine cube theta, and then negative times negative becomes positive sine cube theta cosine theta plus c. Okay, so let us free up some space here. We need to define our sine and cosine, so we refer back to our substitution earlier. We construct a right triangle with the acute angle theta. Okay. So, sine theta is x over 3. Sine theta is x over 3, opposite over hypotenuse. So, the opposite side is x, the hypotenuse is 3. The third side is 9 minus x squared by applying Pythagorean theorem. Okay, so our answer is 81 over 8. 81 over 8 times theta. Our theta is arc sine of x over 3. Arc sine of x over 3 minus, okay, let us factor sine theta. Yes, let us factor sine theta cosine theta. By factoring sine theta cosine theta, what do we have here? Cosine squared theta, right? Cosine squared theta, and then minus sine squared theta. Alright? So that will be negative sine theta is x over 3. Cosine theta is square root of 9 minus x squared over 3 times cosine squared. Cosine squared is square root of 9 minus x squared, or just 9 minus x squared over 3 squared, or 9, minus our sine squared will be x over 3 squared, or x squared over 9. plus c. So 81 over 8 arc sine of x over 3 minus 3 times 3 is 9, then 1 over 9 is 1 over 81. So x square root of 9 minus x squared over 81 times 9 minus x squared is 9 minus 2x squared plus c. Okay, we can distribute 81. So 1 over 8, 81 arc sine of x over 3 minus, we distribute 81, so over 81 that will be 1x square root of 9 minus x squared times 9 minus 2x squared plus c. Okay, so that is our final answer. Let us have another one. We evaluate the integral of x squared all over the square root of 4 plus x squared dx. We start with the radicand, which is of the form a squared plus u squared. A is 2, u is x. So, what do we use for a squared plus u squared? U equal to a tangent of theta. So x is equal to 2 tangent of theta. Taking the differential of both sides, dx is equal to 2 secant squared theta d theta. We apply these substitutions to the integral. X squared becomes 2 tangent theta squared, and then dx is 2 secant squared theta d theta all over the square root of 4 plus x squared is 2 tangent theta squared, or 4 tangent squared theta. So 2 squared is 4 times 2 is 8. Let us write it before the integral sign. In the radical, we can factor 4. It will be 1 plus tangent squared theta, and the square root of 4 is 2. So that is equivalent to 1/2. The numerator, we have tangent squared theta and secant squared theta d theta all over 1 plus tangent squared theta is secant squared theta, and the square root is secant theta. So 8 over 2 is 4. Secant squared over secant, that will cancel secant theta. So what do we have? Tangent squared theta, secant theta d theta. For this, what we do is we apply an identity to tangent squared theta. 1 plus tangent squared equal to secant squared. So we write tangent squared as secant squared theta minus 1 times secant of theta d theta. We distribute secant theta d theta and come up with two integrals, secant cube theta d theta minus the integral of secant theta d theta. Alright? And we know the integral of secant cube, which is 1/2 secant theta tangent theta plus 1/2 ln of the absolute value of secant theta plus tangent theta minus the integral of secant theta d theta is ln absolute value of secant theta plus tangent theta plus c. So that will be 4 1/2 secant theta tangent theta. 1/2 ln minus ln. That will be negative 1/2 ln absolute value of secant theta plus tangent theta plus c. We can factor 1/2, so 4/2, that will be 2. Secant theta tangent theta minus ln absolute value of secant theta plus tangent theta plus c. We shall now define secant and tangent from our substitution earlier. So we have the right triangle here. Theta, tangent theta is x over 2. Opposite over adjacent. So the hypotenuse is the square root of 4 plus x squared. So 2. Secant is hypotenuse, square root of 4 plus x squared over adjacent 2. Tangent is opposite x over adjacent 2 minus ln absolute value of secant square root of 4 plus x squared over 2 plus tangent x over 2 plus c. Okay, so we can distribute the 2. That will be 1/2 x square root of 4 plus x squared. No? So square root of 4 plus x squared times x all over 4 multiplied by 2 is 1/2 minus 2 ln of the square root of 4 plus x squared plus x all over 2 plus c. Now this part is of the form ln m all over n, right? Which is equivalent to ln m minus ln n. So ln of this expression is actually ln of, okay, let me write that. That will be equal to 1/2. Let me use the same color. That will be 1/2 x square root of 4 plus x squared minus 2 ln of the square root of 4 plus x squared plus x minus 2 ln negative negative positive 2 ln of 2 plus c. Okay, ln of a quotient is ln of the difference, or the difference of the ln's. So there's a negative sign. We distribute the negative sign. So 2 ln of the square root of 4 plus x squared plus x minus 2 times the negative of ln of 2. But ln of 2 is a constant and it adds to the other constant c. So finally, our answer will be 1/2 x square root of 4 plus x squared minus 2 ln absolute value of 4 plus x squared plus x plus c. So these two will combine. 2 ln of 2 plus c will combine into a single constant c. So that is our final answer. So let us have another one. The integral of x dx all over the square root of x squared plus 6x plus 10. As the radical is given in the form x squared plus 6x plus 10, there is no exact form. There's no exact form a squared plus u squared or a squared minus u squared or u squared minus a squared. None of this appears in our radical. So what we do is we complete the radical, in particular the radicand, as a perfect square trinomial. So we shall write this as the integral of x dx over the square root of x squared plus 6x plus 9 plus 1, where x squared plus 6x plus 9 is equivalent to x plus 3 squared. So now, what we have as a radicand is an expression u squared plus a squared. U squared plus a squared, or a squared plus u squared, where our u is equal to x plus 3, a is 1. So for the expression a squared plus u squared, we use u equal to a tangent of theta, or x plus 3 equal to 1 tangent theta. Getting the differential, we have dx equal to secant squared theta d theta. So we continue. Our x will be tangent of theta. Tangent of theta minus 3. That will be our x. Tangent theta minus 3. Okay? And dx is, let me write this. Our dx is secant squared theta d theta all over the square root of x plus 3 quantity squared is tangent theta squared, or tangent squared theta plus 1. So we now have tangent theta minus 3 secant squared theta d theta. 1 plus tangent squared theta is secant squared theta, whose square root is secant theta. So, excuse me, we can cancel secant theta and then distribute secant theta d theta, tangent theta, secant theta d theta minus the integral of 3 secant theta d theta. We know the integral of tangent theta secant theta, which is secant theta minus 3. Integral of secant theta is ln of the absolute value of secant theta plus tangent theta plus c. Okay, from our substitution, tangent theta is x plus 3 over 1, opposite over adjacent. Opposite is x plus 3, adjacent is 1, that will be square root of 1 squared plus x plus 3 squared, which of course is equal to the square root of x squared plus 6x plus 10. Alright, so secant is hypotenuse, square root of x squared plus 6x plus 10 all over adjacent, which is 1, minus 3 ln of the absolute value of secant theta, square root of x squared plus 6x plus 10. That should be plus 10 over 1 plus tangent theta x plus 3 over 1 plus c, or the square root of x squared plus 6x plus 10 minus 3 ln of the absolute value of the square root of x squared plus 6x plus 10 plus x plus 3 plus the constant c. There.